It's about 10 years there's a trend from single components to photonic integration. Until maybe 2005 to 2010, the majority of all devices in communications was based on single photodetectors, single lasers, or single modulators. Since then, there was an evolution, like the electronic industry had the 80s of the last century, co-integrate more and more of these components into a single chip so that you reduce the packaging effort and improve stability. There are a couple of material systems which compete for success in the photonic integration industry. For example, the longest experience, I believe, is with indium phosphide, which has the advantage of being able to co-integrate lasers and detectors together with passive waveguides. On the other hand, there's silicon photonics with the large scale effects from the factories they can use, and some other platforms like lithium niobate waveguide or polymer-based passive waveguides. The decision which one of these platforms is going to be successful for which purpose is yet to come. So at HHI, we do have two different integration platforms. One is indium phosphide monolithic, and the other one is polymer-based passive waveguide integration. The polymer-based waveguides have the advantage of having much lower cost per real estate. The dollars per square centimeter is one order of magnitude lower than for indium phosphide. And the other advantage there is that the co-integration with other materials for other purposes is very easy. We started these activities with the attempt to make a $5 tunable laser by combining a 300 micrometer laser chip from indium phosphide with a passive cavity, which is much larger in the polymer platform. And one of the later results is this tunable laser, which we co-developed with ADVA, and where ADVA got the Turing State Prize for Innovation. It's a very exciting field to be in with photonic integration. It's both from the economic side and from the technological side. From the economic side, you have seen in the last 20 years the change from the completely vertical integrated industry, the AT&T Bell Labs and the German Telecom, which did everything from opto-chips to systems. This split up now over the next years then to the complete segregation, where everybody did only a single thing like component systems and aggregation. Now it's vertically integrated, again, with all the system houses acquiring companies like Acacia. So it's very interesting how this is going to end up. And it's very interesting if the business case for photonic integration companies is also viable on a standalone case, where you have to finance your next product generation from the revenues from the last product generation. On the technical side, it's at least the same interesting. On one hand side, you have the scale efficiencies of silicon photonics. And certainly there will be some markets in the 100 million to 200 million pieces per year where this will be the key success factor. On the other hand, you have the very experienced platforms like indium phosphide, and in the last years, you see a revival of lithium niobate and this polymer hybrid integration platform. So the race is open, and I'm pretty sure that there's not a situation where one winner takes it all.
TechCam.